Good day, everyone. Once again, I am Maki Galendez, and I will be discussing the part 2 for renal function, which will be all about the blood urea nitrogen. The non-protein nitrogen compound present in highest concentration in the blood is urea. Urea is the major excretory product of protein metabolism, primarily from dietary sources, but also a byproduct of amino acid catabolism. It is formed in the liver from amino groups, the negative NH2, and free ammonia generated during protein catabolism. This enzymatically catalyzed process is termed as the urea cycle. Since historic assays for urea were based on the measurement of nitrogen, the term blood urea nitrogen, or BUN, has been used to refer to urea determination. However, urea nitrogen, or urea N, is a more appropriate term. Synthesized in the liver from carbon dioxide and ammonia from the deamination of amino acids during the Krebs cycle, protein metabolism produces amino acids that can be oxidized to produce energy or stored as fats and glycogen in the process that we refer to as lipogenesis for fat production and gluconeogenesis, which is the production of glucose from non-carbohydrate sources. The problem is that these processes release nitrogen, which is converted to urea. Pero before siya ma-produce into urea, actually, the first waste product is ammonia. Okay? So, following synthesis in the liver, urea is carried in the blood to the kidney where it is readily filtered from the plasma by the glomerulus. Most of the urea in the glomerular filtrate is excreted in the urine, although some urea is reabsorbed by passive diffusion during passage of the filtrate to the renal tubules. The amount reabsorbed depends on 1. The urine flow rate, and 2. Extent of hydration. Later, you will find out na meron palang importance yun. Kasi nga, di ba? Okay. So, small quantities of urea, about less than 10% of the total, are excreted through the gastrointestinal tract and skin. The concentration of urea in the plasma is determined by the protein content of the diet and the rate of protein catabolism and renal function and perfusion. All of which all of which kay nag-participate sila in the total concentration of urea in the blood. Urea is widely used as a measure of renal dysfunction, but its value as a measure of GFR is not possible. Bakit hindi siya reliable for glomerular filtration rate? Kasi, first of all, it is dependent to the rate of urea production and not solely to the renal function. So, if functioning well ang kidneys mo and then madaming urea sa urine, it is possible because mataas yung urea intake or mataas yung protein intake. Or let's say for example, mababa yung protein intake mo. So you would expect low urea levels. Kasi nga, urea is freely filtered by the glomerulus, but it is reabsorbed. In fact, 40% is reabsorbed in some parts of the nephron. So, hindi yung buong urea na produce ng katawan ang naiihi ng tao. Kasi nga, while it is 100% filtered by the glomerulus, 40% is reabsorbed by the tubules. And remember that some portion of urea is actually being excreted by the gastrointestinal tract and even the skin. So knowing na meron siyang mga caveats, why do we measure blood urea nitrogen? To evaluate renal function. BUN is a key marker for assessing kidney function. Urea is a waste product formed in the liver from protein metabolism and is excreted by the kidneys. If the kidneys are not functioning properly, urea accumulates in the blood, resulting in elevated BUN levels. Therefore, high BUN suggests impaired renal clearance, making it a useful indicator of kidney efficiency. Another, it can be used to assess hydration status. BUN can reflect hydration levels. In dehydration, there's less plasma water. If mababa yung plasma water, then nagko-concentrate yung solutes like urea, causing an increase in BUN. In contrast, overhydration will cause what? 'Di ba hemodilution? So ang dugo nyo, diluted siya, causing what? Remember that BUN is a solute, so lower ang BUN mo. Thus, BUN helps distinguish between pre-renal azotemia, often caused by dehydration, and intrinsic kidney disease. So, urea contains nitrogen. So, BUN reflects the nitrogen content of the blood. Measuring BUN is useful in evaluating what? It is useful in evaluating nitrogen balance, especially in patients undergoing nutritional therapy, trauma, or severe illness. Elevated or reduced BUN levels may signal catabolic or anabolic states respectively. So, nitrogen balance is actually equal to the protein intake, ba yan? Intake minus protein excretion. So again, nitrogen balance is equal to the difference of protein intake minus protein excretion, of which a negative balance indicates that excretion exceeds intake, which occurs in cases of stress, starvation, fever, cachexia, and chronic illness. Okay? So yung cachexia, that has something to do with the muscles. Okay? Other than that, it is also used to aid in the diagnosis of renal disease and to verify adequacy of dialysis. So, so in patients undergoing dialysis, BUN is measured before and after the procedure to evaluate how effectively urea is being cleared. A significant drop in BUN post-dialysis indicates effective treatment. This monitoring is crucial for adjusting dialysis duration or frequency. So remember class, 'di ba, that when a patient is undergoing dialysis, yung patient natin meron na siyang impaired kidney function. So what is typically being filtered by the kidney is no longer being filtered, causing accumulation in the body. So you would expect that that urea is increased pre-dialysis, whereas urea should be decreased post-dialysis. Kasi the role of dialysis is to remove those metabolites, those toxic metabolites and substances that is normally filtered by a working kidney. Okay? So, here are the conversion factors. So, when you measure urea, ito yung factors na gagamitin natin. To calculate for urea in mg per dl, you multiply urea nitrogen times 2.14. And then, to calculate for millimoles per liter, simply convert urea nitrogen in mg per dl by multiplying it to a factor of 0.36 and you get urea in millimoles per liter. So, please do memorize this factor and kung ano yung associated unit of conversion niya. So for the measurement of blood urea nitrogen, you have three methods. One is the conventional or the colorimetric method, the kinetic method, and the chemical method, of which atin silang isa-isahin. So for the measurement of BUN through the conventional colorimetric method, it involves hydrolysis of urea by urease. So, paano ba nagpo-proceed yung reaction? This is the chemical formula for urea. By the action of urease and in the presence of water, urea is hydrolyzed, causing the formation of ammonia and carbon dioxide, of which ammonia is then made to react with either the Nastler's reagent or the Berthelot's reagent. Okay, tingnan natin. So for the Nestler's reaction or the Nestlerization, it uses the Nestler's reagent or the mercuric iodide in alkaline solution such as potassium mercuric iodide. It is then capable of reacting with ammonia to produce a yellow to brown colored complex. Again, yellow to brown colored complex. And it is measured at 450 nanometers. The intensity of the color is directly proportional to the urea concentration in the sample. So, If pronounced yung kulay, meaning to say, mataas yung urea concentration. If hindi siya intense, then mababa lang din yung concentration ng urea. In Berthelot's reaction naman, there is the use of nitroprusside. The principle is that ammonia reacts with phenol and hypochlorite in the presence of a catalyst such as the alkali nitroprusside or the sodium nitroprusside. So, yung indophenols natin, nagkaka-develop sila ng color at alkaline conditions in the presence of alkaline nitroprusside, resulting in the formation of a blue colored indophenol complex. So still, the intensity of the blue color is measured spectrophotometrically and reflects urea concentration. So, ang blue compound measure at 540, ang yellow to brown compound measure at 450. Please do not mix up the two. 450 and 540. Nestler's reaction, 450. Berthelot's reaction, 540. Now let's move on to the kinetic method or the coupled enzymatic reaction for BUN. Kanina, we've used urease and then the Berthelot's as well as Nestler's reaction. Pero ngayon, because we're using a coupled enzymatic assay, urease is coupled with another enzyme that is glutamate dehydrogenase. So BUN is most frequently measured by the urease UV method, in which the urease reaction is coupled to the glutamate dehydrogenase reaction, generating NAD+. Okay? When the urease reaction is performed under first order conditions, the decrease in absorbance at 340 nanometers is proportional to the urea concentration. Again, ganito, if you remember in our discussion sa carbohydrates, di ba? Ang NADH is high absorbance at 340. But if you look at the reaction, ano yung naproproduce? Di ba NAD ang naproproduce? We measure NAD at the same wavelength. Pero, we do not measure its absorbance. Rather, we measure the loss of absorbance. Meaning to say, as NAD concentration increases, the absorbance decreases. But as absorbance decreases, concentration of urea increases. Again, di ba, urea? And then, by the action of urease, it is hydrolyzed to form ammonia. Ammonia is made to react with 2-oxoglutarate by the action of GLDH, resulting in the conversion of NADH into NAD+. Ngayon, if NAD increases in concentration, its absorbance at 340 nanometers decreases, of which the decrease in absorbance is directly proportional to the concentration. Decrease in absorbance is directly proportional to the concentration. Klaro ba? Disappearance of NADH, pwede din appearance of NAD+. They are the same. Okay? And then you also have your chemical method, which makes use of diacetyl monoxide, which is a direct method. Bakit siya direct method? Because urea reacts directly with diacetyl monoxide in strong acidic conditions to form a yellow diazine derivative at 540 nanometers. So, dalawa na ang 540 nanometers. Okay? Meron tayong 450 nanometers for the Nestlerization. Meron tayong 540 nanometers for the blue indophenol complex formed in what? Formed in the Berthelot's reaction. And meron din tayong 340 nanometers decrease in absorbance by the production of NAD in the coupled enzymatic reaction for the measurement of BUN. And ngayon, sa chemical methods, meron na din tayong yellow diazine derivative measured at 540 nanometers. So, dalawa na ha. Yellow diazine at 540 nanometers, meron ding blue indophenol complex by the Berthelot's reaction still at 540 nanometers. Pero, yung diacetyl monoxide natin, it is added with ferric ion and thiosemicarbazide. For what? Because it stabilizes color and intensifies the reaction. Okay, so let's look at the reaction. Diacetyl monoxide is actually hydrolyzed to produce diacetyl and hydroxylamine, of which diacetyl participates in the reaction. Diacetyl directly reacts with urea in an acidic medium, causing the formation of a yellow diazine derivative that is measured at 540 nanometers. Now, among the three, meron tayong reference method na the coupled enzymatic assay, wherein you use urease and GLDH. However, in modern times, we actually would opt to use the isotope dilution mass spectrometry. Ganito siya, class. The isotope dilution mass spectrometry is not applicable in most laboratories. Applicable siya for research. So, if tatanungin kayo, class, dalawa talaga ang reference method. Pero ang pinaka ginagamit ng mga laboratories is yung urease coupled enzymatic assay. Etong isotope dilution mass spectrometry, it determines unique spectroscopy fragments through mass spectrometry and quantification using isotopically labeled compound. It is not recommended for routine tests since the assay is expensive. So, ano ba yung dilution in isotope dilution mass spectrometry? The labeled urea acts as an internal standard. Okay, when this labeled compound is mixed with the patient sample, it dilutes concentration of the unlabeled or the natural urea. So ganito yan siya, class. Meron kang reagent urea na merong label. Yung urea na may label, gi-add mo siya sa patient sample na merong urea na walang label. Yun yung tinatawag natin na natural urea. The mass spectrometer then measures the ratio of the labeled, which is yung reagent mo, and the unlabeled, which is yung sa patient, urea. Using this ratio, the true concentration of the natural urea in the sample is calculated very precisely. Example, imagine that you spike 1 milligram of N-urea into a patient sample. After analysis, the mass spectrometer finds a 1:2 ratio of labeled to unlabeled urea. 'Di ba? 1 mg ang labeled mo. Tapos ang ratio daw is 1:2. So you would expect that merong 2 milligrams of natural urea present in the sample. And that is the principle of isotope dilution mass spectrometry. Again, dalawa yung reference method. One is the urease coupled enzymatic method using GLDH and urease, and the other is the isotope dilution mass spectrometry. Ano ang ginagamit in the laboratory? Typically, it's the urease coupled enzymatic assay. Ano yung for research or ano yung mas applicable if we want a more sensitive method, then you would opt for the isotope dilution mass spectrometry. Pero downside is expensive yung IDMS. Okay? So for the specimen requirements, urea concentration may be measured in plasma, serum, or urine. So if plasma is collected, ammonium ions and high concentrations of sodium citrate and sodium fluoride must be avoided. So, avoided dapat ang sodium citrate, ang blue top, ang light blue. Ano pa? Sodium fluoride. Hindi din pwede ang gray top. Kasi they inhibit urease. Although the protein content of the diet influences urea concentration, the effect of a single protein-containing meal is minimal and a fasting sample is not required usually. Kaya nga, hindi kailangan mag-fasting. Kasi when you measure blood urea nitrogen, it does not spike because you ate protein ngayon. Rather, ang BUN concentrations kasi ng blood is dependent on the actual diet, kung gaano ka nakatagal na mataas yung protein intake mo. Kaya typically, fasting specimen is not required. Okay. So, a non-hemolyzed sample is recommended. Urea is susceptible to bacterial decomposition. So, specimens, particularly urine, that cannot be analyzed within a few hours should be refrigerated. Ganito siya kasi siya, class. Um, your urine may contain bacteria, and some bacteria has urease. So what happens? Urea in urine is broken down by the urease produced by your bacteria, causing falsely low report. So how are you going to inhibit, not kill the bacteria, but inhibit its metabolism? By placing it in a refrigerator. Because refrigerator temperatures are bacteriostatic. By the way, ano ba yung urine natin? Is it random urine? No. The urine that we get is a timed urine. What do we mean by timed? Kailangan ba natin siya kunin at 3 a.m., 4 a.m., 5 a.m.? Hindi. What we meant by timed is that typically, the one that we use in the laboratory is a 24-hour urine specimen. Kung pasabot sa 24-hour urine. For 24 hours, the patient should collect all of his urine except for the first urine voided of the day up to pwede ka after first voided, yung second voided ka mag-start ng collect. And then collect all of the rest of the urine for the day for 24 hours. And also, the first voided urine of the following day is also part of the 24-hour collection. Okay? So, no alcohol intake at least 8 hours before blood draw. Methods for plasma or serum may require modification for use with urine specimen because of high urea concentration and the presence of endogenous ammonia. Bakit hindi pwede mag-alcohol intake? Because ethanol lowers urea by more than 10%. Okay? So for the summary, ito na yung mga methods natin for the detection of urea. You have your GLDH coupled enzymatic assay, you have isotope dilution mass spectrometry, meron ding urease together with the addition of Bertholot's and Nestler's, and meron ding the presence of indicator dyes for automated systems. Meron ding conductometric. Okay? So for the reference ranges, please do memorize the reference ranges. One is for the plasma or serum and the other is for urine, particularly at 24-hour urine. For 24-hour urine, first urine voided is not part of the 24-hour urine, and the first urine voided following 24 hours is part of the 24-hour urine. Okay? And ano nga yung storage? Refrigerated para maging bacteriostatic to inhibit bacteria from proliferating and metabolizing urea if they are urease producing. So memorize these values, especially their units.